More examples of solving trig equations. First, we have one that says find all solutions of sine squared 4x equals 1/4. The big thing always with any kind of algebra is how many times does the variable appear? Okay. If it's just once, and in this case, then we're really just stripping off layers. And what's the outer layer? It's the square. We want to take the square root of both sides, because this is really the quantity sine 4x all squared. And so this is going to be plus or minus square root of 1/4, which is 1/2. Okay. Now, the next thing to do is to strip off the sine. And one thing I should have said right at the start is this process of stripping off layers, it always goes from the outside in. This 4x often really bothers people. How do I've never seen sine of 4x before. Well, you actually have, but sometimes people feel like, oh, that's new. And the key thing is that that's in the innermost layer. If we start stripping off the layers, like the square and then the sine, the last thing we're going to deal with is this 4x. Maybe let's put this in parentheses to emphasize that. So we're just saying the sine of some mystery quantity is plus or minus 1/2. We can say what this mystery quantity is just based on that. And only then will we have to deal with the 4. Let me show you how that works. So if sine of blah is plus or minus 1/2, well, that's one of our standard values. We go to the unit circle, plus 1/2 minus 1/2, plus 1/2 minus 1/2. All these pi over 6s. Okay? And in fact, we could go ahead and use a plus or minus. We could think of this as minus pi over 6. And we could think of this as minus 5 pi over 6. So that'll make it a little more efficient to write down. And so 4x is either plus or minus pi over 6 or plus or minus 5 pi over 6. Now we need the whole pattern. Let's see. This is all solutions, not just in one trip around the unit circle. Okay. And so that's plus 2k pi, or 2 pi k. I don't know which way I was doing it last time. And then this is also plus 2 pi k. Okay. So I haven't had to deal with the 4 yet. It's been in the inner layer. It hasn't affected me. Even if this was a 2, the 2 case is actually the most confusing because you do know an identity for double angles. And the key thing is that here, in this kind of situation, there's no need for a multiple angle identity. We will see a use for it later, but not here, because there's nothing really weird about the 4x. The only time the 4x comes in is at the end here, and guess what? It's not hard to deal with the 4 now. We purposely don't deal with it until we need to, and then we just divide everything by 4. So let me just copy this. I'm just going to divide everything by 4. So plus minus pi over 24 plus pi k over 2. And then here again, 5 pi over 24 plus pi k over 2. That's it. That's all you have to do. So this is a crucial one to not overcomplicate. Okay. So another thing to notice, and this is going to be really crucial in the next version of the problem, is that when does the plus 2 pi k come in? Okay. A lot of people think that's something I do at the very, very, very end of a problem. And I just put it on, and the teacher told me to do that. That's not what's going on. It's always when you say, I've got a mystery angle that has a certain position on the unit circle. It's when you strip off the trig function, and it's when the pi's and the trigs first appear. Okay, so let me put a note about that. The 2 pi k, the 2 pi k's appear when the trig function is stripped off. Okay. Often, in a simple version of the problem, that might be right at the end of the problem. But here it's not. It's when that 4x is uncovered. And then you divide by 4. So it's not a plus 2 pi k. That is not some general rule that the answer is always, always, always plus 2 pi k. This 4x is going around the unit circle 4 times as fast as x does. And so it takes a fourth of as much to get back to the same place on the unit circle. Okay. So what about find all solutions in 0 to 2 pi? Okay. So now that is very similar to this problem. It's just the other instruction, but for the same exact equation. So some of it's going to be the same, but it's going to be a little tricky because we only want these to be within 0 to 2 pi. However, this phenomenon that these x's got divided, these numbers got divided by 4 to produce the answers for x is going to be significant. Let me show you how I like to do this. Okay. First thing, first thing, before doing any algebra with the actual equation, is I look at this 4x, okay, and I say if, and I'm going to translate this into inequalities, if 0 less than or equal to x less than 2 pi. Oops. Okay. What does that mean about 4x? Because you notice that was what popped out when we did the unit circle. When we went to the unit circle and found out the correct radian values, that's what was popping out, 4x, not x. And so it means that 4x actually is going between 0 and 8 pi. Okay. That means 4 times around the unit circle. Okay. That's going to turn out to create a long list of possible answers. Okay, so now let's go ahead and do the algebra. We know the first step is just to here. Okay. Then the next step is we strip off the sine function, 4x equals. Now, here's where we need to stop, okay? We don't need minuses because we don't need any of the anything in it with a negative number. This is what the 4x's are supposed to be. But we do need to get explicit values without the k's, okay? So what we're going to do, this crucial observation that the 4x goes 4 times around a unit circle when x goes once around means we're just going to look at that unit circle. We're going to look at all the mystery angles that give us plus or minus 1/2 as we go 4 times around the unit circle. So let's see what that's going to be. It's going to definitely start with pi over 6, and then 5 pi over 6, and then 7 pi over 6, and then 11 pi over 6. And we really are using the positive versions now because it's required. And then 13 pi over 6, and then 17 pi over 6, and we're just going to keep going. It's going to be a lot. I don't know if I should have picked 4, but let's see. Okay, so it's going to be pi over 6. I'm going to start copying here. Okay. Then 5 pi over 6, then 7 pi over 6, then 11 pi over 6. That's one trip around, but we're not done yet because 4x is not what's between 0 and 2 pi. X was between 0 and 2 pi. 4x goes all the way up to 8 pi. It's going to be a really long list, actually. So then the next one is 13 pi over 6. The rule is we've got the sort of the one trip around here. We're just going to add 2 pi's repeatedly to all these base cases. So it's going to be 17 pi over 6 because 12 pi over 6 plus 5. Then the next one is going to be 12 plus 7 is 19 pi over 6. Usually we wouldn't do a 4 because it's just kind of tedious, but I just decided to do something different from what was in the book. 11 plus 12 is 23 pi over 6. That's 2 times around. Whew, still not done. Now we're going to add 24 pi over 6 to our base case, or equivalently 12 pi over 6 to these guys. We're just adding 2 pi's, going around and around the unit circle. And so 12 plus 17 is 29. Whoa, not 289. And 12 plus that's 31. And then 12 plus 23 is 35 pi over 6. And let's see, is that getting close to 6 pi? Yes. 36 pi over 6 would be 6 pi. And just one more trip around. 37. We're adding 36 pi over 6 to the base cases right here. 41 pi over 6. Is it going to fit? I don't know. 43. And finally, 47. And that should be just short of 8 pi, because 48 pi over 6 would be 8 pi. Whew! No comma necessary. Wow! That's ridiculous. But that's what happens if you've got a multiple angle kind of situation. You get a lot of possibilities. Because, and it's the same kind of thing here. These numbers are really small. Okay. And you get a lot of possibilities, even with one trip around the circle for x. Now we just divide by 4. Okay, and so all these denominators just turn into 24s. And we could have gotten this by just looking. The alternate way to do this, especially given that we had done the other version before, is we could have looked at the previous solution to version number 1 and just looked for which of these are in the right region. I find this method, especially if you haven't done the general method first, the general version first with the k's, I find this method to be best. Just make sure you know whatever's in the sine function or cosine or whatever trig function, figure out where that lives, and make your list here. Okay, so we're making our list before the last step of the problem, and then finally we divide by 4. Woo! Again, this is more things than you'd usually have to do. If you really look at this and you say, okay, I take pi over 4 and 5 pi over 24, these are these two base cases, and the minuses, and I add in over 2's, I will actually get this list, but this is a more explicit way to do it. Okay, I'm going to save 3 for another video.